So welcome to this afternoon. We're going to go through a little bit about, I'm going to talk a little bit about DTEX, and I get the opportunity and the privilege to introduce some of the other speakers for in this company session. So a little bit about DTEX. We're a company founded in 2006, and we do molecular detection. And what I thought I'd do is we kind of look at the problem that some of our technology might solve. And we started out looking at how long it took for the industry, the food and the water industry, to detect pathogens in wherever it might be, in the food or the water. And as it happened, it can take up to like 5 days to get results back if something is being cultured. And that seemed like a problem. There seemed to be some risk associated with that. The folks at Maple Leaf, Randy there, said it takes about a week to get results back on listeria. So clearly there was a problem. Our technology is designed to detect pathogens at the molecular level in about 5 minutes or less. So, but the trick is that has to be comparable to, a Petri dish in the standard way that tests are done today, or else that would be interesting but not a lot of use. There are other technologies like DNA using PCR that will detect in 10, 12 hours, sometimes a little bit less. So, but still that 5 minutes gives us a pretty interesting mark. And then of course we looked at how do we keep it low cost and easy to use, because that all has to go hand in hand. And when we looked at that, it's not just us. There's other folks coming out there, and I put this slide up here just to say that there is ongoing trends in this molecular detection with increased sensitivity. And we heard this morning that there's other people working on these types of technologies, which is good to see. So when we looked at this, I took a look at the food chain, where food kind of starts and where it can kind of go through the chain. And we had different comments back from the people in the industry. And I just wanted to share with you some of those thoughts as we kind of work through the food chain. So the food chain, I've just put the slide up here. You can kind of see we start at the farm and the ranch, and we go into the raw materials, the slaughterhouse, food processors, onto retail and the consumer. So we're just going to talk a little bit about some of the attitudes and some of the feedback that we got as we went through this. So if you're from the agriculture sector, which is very appropriate to be sitting here today, just think about how some of this early detection could affect you. Where would you care about early detection, and where could some of this technology be a benefit? That's kind of the thought. So I talked to some folks on the soil testing early on and said, hey, well, what if you could drive your tractor down the field and have instant testing of exactly what's in your soil? So you could map it all out, tie it to your GPS system, so now your tractor knows exactly, your sprayer knows exactly how much fertilizer to be putting on as it dries, because it knows the characteristics of the field. Would that change land values? I don't know. It was an interesting discussion. Wheat fungus, or fungus in general. What if you could instantly detect fungus? Is there any value to that? There's a mutant grain fungus, UG99, that was found in Uganda, threatening large portions of the world's wheat. And maybe detection in this case is more, if it's cheap and if it's widely deployed, that could be of interest. Get it in the hands of a lot of people, so when this stuff starts to come to North America, maybe instantly we can know what's going on. I don't know. The treatment of this is fairly simple, but maybe the detection is wider spread. As we move up the food chain, we had discussions with some vets who said the monitoring water in the trough. So we could instantly tell when a cow was drinking what disease they had. Now maybe it would tie into some of that RF technology there, and you'd know exactly which cow it is and track them right from where he's going to go from there. But you'd know instantly what disease he had. Is that, there's some interest for instant detection. Down the food chain, we talked to some folks about stressed animals heading through into the slaughterhouse, right? So when those guys get stressed out, that changes the quality of meat. So they don't want to actually slaughter that animal at that point. They take them they would like to take them out of the lineup, give them a hot shower, a nice meal, I don't know, and then, back in later, feeling a lot better. Now we're talking increased value. As we move down the chain, we talked a lot to food processors, and here, this picture actually, well, never mind. But so, the food processors are actually fairly eager to test instantly to know what's there, and the reason is because if you're producing something, you can get it out the door quite a bit quicker. You can have a fresher product. So there's some business reasons, less chance for a recall, right? If you know that product was safe when it left. But also there's an attitude of test to not find that we found the attitude. The test to not find is where you have a surface and then you clean it really good and then you test that surface. And guess what? You don't find anything. So then when you report to the regulatory bodies that you didn't find anything, that looks really good. So one of the things then the reason that I bring this up is because as we create technology, it's important for us to understand from the industry's perspective what's really going on. What's the real motivation, right? Because if we don't understand that, we can easily create technology and completely miss the market. That happens all the time. I put this note in here on retail just because Dole had 100,000 juice boxes that had to be destroyed, and that in itself isn't that interesting, but they didn't actually package it. So Dole, kind of third party that whole process out, but their name is associated with it. So we can start to see where it's important for folks to be able to control what their partners are doing, or else they're going to end up wearing the problem. Down the chain a little bit, I just wanted to talk a little bit about consumers, because I can see where you can have technology in the hands of the rest of us. We all eat, we're all wondering what we're eating. And as it happens, right now, this is a new study from IBM out that says less than 20% of consumers trust food companies to develop and sell foods that are safe and healthy. Now, I'm not that good with the math, but I think we're looking at 80% of people that aren't that thrilled here. So, and in the hands of people that kind of think like this, how might this new technology, detection technology, instant, affect things? And there is some cause for ongoing concern, but it has to be balanced. There's a couple thousand cases a year of listeria, and I think most of us have probably heard of listeria and how bad that can be. And it can be bad. I mean, 20% of people that get a certain type of listeria, it's fatal. So, but there's not that many cases. Although, that said, it's increasing in Europe, and they don't know why. They think, and it's mostly in folks that are over 55, which might suggest maybe they're keeping their food too long in the fridge, because listeria can also grow in a cold environment, and it's getting them. And it does take millions of cells to actually make you really sick, so it's not like one cell is going to get you. And yet the regulatory folks say, regardless of the types of listeria that there are, we want to know if there's we want the tolerance to be zero, no listeria. And part of the challenge is that reasonable? Because if you get regulatory's policy that's unreasonable, then you get industry saying, well, let's test to not find, because that's not really, we're not all playing in a very good game here, right? So these kind of technologies, I think this instant detection starts to bring some of these issues to light.